So this is the shear resistance of soils continued. So we got at any point in a two-dimensional stress system, there will be two planes on which there are no shear stresses. These are known as the principal planes, and the normal stresses, sigma 1 and sigma 3, are known as the major and minor principal stresses. Right, in figure 4.2a, two principal stresses, sigma 1 and sigma 3, act at... Oh, wait, hold on. Is this one? So complicated. I'm having trouble understanding it myself, to be honest. In figure 4.2a, two principal stresses, sigma 1 and sigma 3, act an inclination is at delta to the vertical and horizontal axis. On any other plane x-axis inclined at gamma to sigma 3, there will be normal stresses sigma n and a shear stress tau. Resolving the forces on the plane give sigma n equals sigma 1 plus sigma 3 divided by 2 plus sigma 1 minus sigma 3 divided by 2 cos 2 delta. Tau equals sigma 1 minus sigma 3 divided by 2 sine 2 alpha. Right, I'll come back to that diagram, I think. Resolving the forces equations 4.2 and 4.3. Resolving the forces on the plane gives those results. And then equation 4.2 and 4.3 are the parameters of a circle with center sigma 1 plus sigma 3 divided by 2 and radius sigma 1 minus sigma 3 known as a Mohr's circle. Figure 4.2b. More Coulomb failure envelope. Blimey, that's quite complicated, isn't it? So many lines and angles and stuff. There's no like description of what they are or what they mean. I think what we're going to have to do is work through a few of these. You got to be able to draw this on your own, and this diagram. I think you have to really be able to redraw it, and this equation you've got to be able to rewrite it. So otherwise you can't really understand. You don't understand it. For any plane passing through P in a soil mass at an angle of gamma, to the minor principal stresses, OX represents the normal stress on the plane, and XY the shear stress, and XOY represents the angle in which the resultants of these two stresses act on the plane. Shear failure will occur when the shear stress increases to a value line on the failure envelope corresponding to the normal stress. This value also lies on the Mohr's circle, and so the failure envelope is tangential to the Mohr's circle at this point. This corresponds with the Coulomb line in figure 4.1, and the result is known as the Mohr-Coulomb failure criteria. Under certain circumstances, clay soils exhibit a cohesive resistance to shearing C, which for any particular soil remains constant, and the Mohr-Coulomb failure envelope may be modified as shown in figure 4.3. That's this one. This resistance is known in terms of effective stress and the apparent cohesion C dash. So that's all right. I can understand that. So you got Y shear stress at failure, X normal effective vertical stress sigma at dash, tau equals C dash plus sigma dash tan delta. Is that phi dash? The angle of that line is phi dash, and the C dash is like, so it's linear, but just with, isn't that the form of, yeah, right, Y equals function X plus constant. Yeah. C's also like the constant is, but you compare it to mathematical things. So then it says the Moore Coulomb failure criterion can then be expressed as A at TF equals C dash plus sigma dash 10 phi dash. Under undrained conditions, a saturated clay appears to have a constant limiting shear strength known as the undrained cohesion or undrained shear strength Cu, and TF equals Cu. Oh yeah, I'll read that again. Under undrained conditions, a saturated clay soil appears to have a constant limiting shear strength known as the undrained cohesion or undrained shear strength Cu, and TF equals Cu. Okay then, so that's the basically first section done. We're coming back to all that to look at what we got to do. We need to look at this equation. Oops, sorry. We've got to look at these equations, and then we've got to redraw this diagram and try and figure out what that's doing. And this diagram is, yeah, we need to redraw it, so it's so complicated, isn't it? And that diagram's okay. Okay then, so hopefully I'll see you in the next video.